Aquatic ecosystems consisting of water as the main habitat are known as aquatic ecosystems. Aquatic ecosystems are classified based on their salt content. Freshwater ecosystems. The salt content of fresh bodies is very low, always less than 5 ppt, parts per thousand. E.g. lakes, ponds, pools, springs, streams, and rivers. 2. Marine ecosystems. The water bodies containing salt concentration equal to or above that of seawater, i.e., 35 ppt or above. E.g. shallow seas and open ocean. 3. Brackish water ecosystems. These water bodies have salt content in between 5 to 35 ppt. E.g. estuaries, salt marshes, mangrove swamps and forests. 4.1 Aquatic organisms. The aquatic organisms are classified on the basis of their zone of occurrence and their ability to cross these zones. The organisms, both flora and fauna, in the aquatic ecosystem are unevenly distributed but can be classified on the basis of their life form or location into 5 groups. Newston. These are unattached organisms which live at the air-water interface, such as floating plants, etc. Some organisms spend most of their lives on top of the air-water interface, such as water striders, while others spend most of their time just beneath the air-water interface and obtain most of their food within the water. E.g., beetles and backswimmers. 2. Periphyton. These are organisms which remain attached to stems and leaves of rooted plants or substances emerging above the bottom mud, such as sessile algae and their associated group of animals. 3. Plankton. This group includes both microscopic plants like algae, phytoplankton, and animals like crustaceans and protozoans, zooplankton, found in all aquatic ecosystems, except certain swift-moving waters. The locomotory power of the planktons is limited so that their distribution is controlled, largely, by currents in the aquatic ecosystems. 4. Nekton. This group contains animals which are swimmers. The nektons are relatively large and powerful as they have to overcome the water currents. The animals range in size from the swimming insects, about 2 mm long, to the largest animals, the blue whale. Bent hose. The benthic organisms are those found living in the bottom of the water mass. Practically every aquatic ecosystem contains well-developed bent hose. 4 factors limiting the productivity of aquatic habitats. Sunlight and oxygen are most important limiting factors of the aquatic ecosystems, whereas moisture and temperature are the main limiting factors of terrestrial ecosystem. Sunlight penetration rapidly diminishes as it passes down the column of water. The depth to which light penetrates a lake determines the extent of plant distribution. Based on light penetration and plant distribution, they are classified as photic and aphotic zones. Photic zone, it is the upper layer of the aquatic ecosystems, up to which light penetrates and within which photosynthetic activity is confined. The depth of this zone depends on the transparency of water. Both photosynthesis and respiration activity takes place. Photic, or euphotic, zone is the lighted and usually well-mixed portion that extends from the lake surface down to where the light level is 1% of that at the surface. Aphotic zone, the lower layers of the aquatic ecosystems, where light penetration and plant growth are restricted, forms the aphotic zone. Only respiration activity takes place. Aphotic zone is positioned below the littoral and photic zones to bottom of the lake where light levels are too low for photosynthesis. Respiration occurs at all depths, so the aphotic zone is a region of oxygen consumption. This deep, unlit region is also known as the profundal zone. Winter-kill snow cover of ice on water body can effectively cut off light, plunging the waters into darkness. Hence photosynthesis stops but respiration continues. Thus in shallow lakes, the oxygen gets depleted. Fish die, but we won't know it until the ice melts and we find floating fish. This condition is known as winter kill. Dissolved oxygen, Times in aquatic ecosystems oxygen is dissolved in water, where its concentration varies constantly depending on factors that influence the input and output of oxygen in water. Times in fresh water the average concentration of dissolved oxygen is 0.0010%, also expressed as 10 parts per million or 10 ppm, by weight, which is 150 times lower than the concentration of oxygen in an equivalent volume of air. Times oxygen enters the aquatic ecosystem through the air-water interface and by the photosynthetic activities of aquatic plants. Times therefore, the quantity of dissolved oxygen present in an ecosystem depends on the rate at which the aforesaid two processes occur. Times dissolved oxygen escapes the water body through air-water interface and through respiration of organisms, fish, decomposers, zooplanktons, etc. Times the amount of dissolved oxygen retained in water is also influenced by temperature. Oxygen is less soluble in warm water. Warm water also enhances decomposer activity. Therefore, increasing the temperature of a water body increases the rate at which oxygen is depleted from water. Times when the dissolved oxygen level falls below 3 to 5 ppm, many aquatic organisms are likely to die. Other limiting factors which influence on aquatic productivity are transparency. Times transparency affects the extent of light penetration. Times suspended particulate matters such as clay, silt, phytoplankton, etc. make the water turbid. Times consequently it limits the extent of light penetration and the photosynthetic activity in a significant way. Temperature. Times the water temperature changes less rapidly than the temperature of air because water has a considerably higher specific heat than air, i.e. larger amounts of heat energy must be added to or taken away from water to raise or lower its temperature. Times since water temperatures are less subject to change, the aquatic organisms have narrow temperature tolerance limit. Times as a result, even small changes in water temperature are a great threat to the survival of aquatic organisms when compared to the changes in air temperatures in the terrestrial organisms. The classification of organisms and limiting factors discussed here apply in general to all aquatic ecosystems, lakes, ponds, rivers, streams, estuaries, oceans and seas. Do you know? Bats are social animals. They hang upside down when they sleep. They feed at night, they are nocturnal, and spend the day sleeping in caves or in tree tops. They are the second largest group of mammals after rodents. Lake ecology. Any body of standing water, generally large enough in area and depth, irrespective of its hydrology, ecology, and other characteristics is generally known as lake. 4-1 aging of lakes. Times like any organism, lakes are born as they originate by various geological and geomorphic events, and grow, with time to change in their various morphological and functional characteristics and eventually die. Times they receive their water from surface runoff, sometimes also groundwater discharge, and along with it various chemical substances and mineral matter eroded from the land. Times over periods spanning millennia, aging occurs as the lakes accumulate mineral and organic matter and gradually get filled up. The nutrient enrichment of the lakes promotes the growth of algae, aquatic plants and various fauna. This process is known as natural eutrophication. Similar nutrient enrichment of lakes at an accelerated rate is caused by human activities, discharge of wastewaters or agricultural runoff, and the consequent aging phenomenon is known as cultural eutrophication. Do you know? Poison dart frogs live in rainforest habitats in Central and South America. They can be found in trees, as well as under leaves and logs and rocks on the floor of the forest. Because of their size, from 1/2 to 2 inches long, they are hard to see. Poison frogs warn predators with brilliant colors and patterns. There are many species of poison frogs that can be found in every color under the sun. They prey on invertebrates, especially certain ant species, which build up really strong poisons in the frog. 422 in India. Times in India, natural lakes, relatively few, mostly lie in the Himalayan region, the floodplains of Indus, Ganga and Brahmaputra. Times in the semi-arid and arid regions of western and peninsular India, tens of thousands of water bodies have been constructed over millennia. Times Lake Sudarshan in Gujarat's Girnar area was perhaps the oldest man-made lake in India, dating back to 300 BC. Times lakes are also classified on the basis of their water chemistry. Based on the levels of salinity, they are known as freshwater, brackish or saline lakes, similar to that of classification of aquatic ecosystem. Times on the basis of their nutrient content, they are categorized as oligotrophic, very low nutrients, mesotrophic, moderate nutrients, and eutrophic, highly nutrient-rich. Times vast majority of lakes in India are either eutrophic or mesotrophic because of the nutrients derived from their surroundings or organic wastes entering them. 423 General characteristics of oligotrophic and eutrophic lakes. Type of lake SL. No parameter. Oligotrophic, eutrophic. 1. Aquatic plant production low, eliminated due to eutrophication. 2. Aquatic animal production low, eliminated due to eutrophication. 3. Aquatic plant nutrient flux low, high. 4. Oxygen in the hypolemnian, bottom layer, present, absent. 5. Depth tend to be deeper, tend to be shallower. 6. Water quality for domestic and industrial uses good, poor. 7. Total salts or conductance usually lower, sometimes higher. 8. Number of plant and animal species many, fewer. 424 Removal of the nutrients from a lake times flushing with nutrient poor waters. Times deep water abstraction. Times on-site P elimination by flocculation, flotation with water backflow, or floating plant Nessie with adsorbents. Times on-site algae removal by filters and P adsorbers. Times on-site algae skimming and separator thickening. Times artificial mixing, destratification, permanent or intermittent. Times harvest of fishes and macrophytes. Times sludge removal. Downloaded from www.upskmaterials.com/downloaded from. Unsuitable Lake. First Biodiversity Heritage Site. Unsuitable Lake gets the status of the first Biodiversity Heritage Site in the country under the Biodiversity Act, 2002. It is an ancient man-made lake in the western part of Telangana. Biodiversity Heritage Site is areas of biodiversity importance, which harbor rich biodiversity, wild relatives of crops, or areas, which lie outside the protected area network. Biodiversity heritage sites are managed by a locally constituted biodiversity management committee and get funding for its protection. Do you know? Under Green India Mission, GIN, perspective plans and annual plans of operations of 6 states have been approved in the first sitting of the National Executive Council held in May 2015. 4.3 Eutrophication times Greek word eutrophia means adequate and healthy nutrition. Times eutrophication is a syndrome of ecosystem, responds to the addition of artificial or natural nutrients such as nitrates and phosphates through fertilizer, sewage, etc. that fertilize the aquatic ecosystem. Times it is primarily caused by the leaching of phosphate and, or nitrate-containing fertilizers from agricultural lands into lakes or rivers. Times the growth of green algae which we see in the lake surface layer is the physical identification of an eutrophication. Times some algae and blue-green bacteria thrive on the excess ions and a population explosion covers almost entire surface layer is known as algal bloom. This growth is unsustainable, however. Times as algal bloom covers the surface layer, it restricts the penetration of sunlight. Diffusion of gas from atom times oxygen is required by all respiring animals in the water and it is replenished by diffusion and photosynthesis of green plants. Times the oxygen level is already low because of the population explosion and further oxygen is taken up by microorganisms which feed off the dead algae during decomposition process. Times due to reduced oxygen level, fishes and other aquatic organisms suffocate and they die. Times the anaerobic conditions can promote growth of bacteria which produces toxins deadly to aquatic organisms, birds and mammals. Times all this eventually leads to degradation of aquatic ecosystem and death of its organisms. Times it often leads to change in animal and plant population and degradation of water and habitat quality. Process of eutrophication downloaded from www.
Process of eutrophication. Then first process is from sunlight. Nutrients, loads of excessive nutrients from the fertilizer are flushed from the land into the river or lake by rainwater. Then second is plant flourish. These polluants use aquatic plant growth or algae, duckweeds and other plants. Next, algae blooms. Oxygen is depleted. Algae blooms, preventing sunlight reaching other plants. The plant die and oxygen in water is depleted. Next, decomposition further depletes oxygen. Dead plants are broken down by the bacteria decomposition and using up even more oxygen in the water. And fifth is death of ecosystem. Oxygen level reach a point where no life is possible. Fish and other organisms are die. Then that process is called eutrophication.
Type 1 natural times deposition of nutrients, such as depositional environments. When the nutrients flow into the system on temporal basis. Times it occurs over centuries times, e.g. seasonally inundated tropical floodplains to man-made times occurs in decades times. These inputs may come from untreated sewage discharges, runoff of fertilizer from farm fields, golf courses, park, etc. and from animal wastes. Times combustion of fossil fuel produces gases, nitrogen oxides times growing urban population in the coastal areas. 432 sources 1 point sources times directly attributable to one influence times in point source nutrient waste travels directly from source to water. Times point sources are easy to regulate. Trees timber. The first and the foremost use of trees are restoration, reclamation and rejuvenation of denuded and disturbed soils by using trees to control soil erosion and desertification, protect watersheds, improve soil nutrient status by growing nitrogen-fixing trees, and retain moisture in the soil. Ecological, eco-developmental and environmental use of trees for effective and efficient purification of the environment because trees act as oxygen banks and eliminate air pollutants, for abating or moderating temperature, noise and wind by planting trees as environmental screens, thus affecting the microclimate, for harboring wildlife, for maintaining biodiversity, and for conserving energy. Educational and recreational value in gardening, landscaping, art, culture and religion. Source of sustenance, i.e., food, fuel, fodder, fertilizer, fiber, medicine, tannin, dyes, oils, etc. 2 non-point source times is from various ill-defined and diffuse sources times vary spatially and temporarily and are difficult to regulate. Flowchart: agricultural runoff, untreated sewage, etc. Transportation to the aquatic ecosystem, nutrient accumulation and enrichment, overgrowth of algae, algal bloom, algae covering the aquatic surface layer restricts the sunlight penetration, diffusion of DO underground aquatic algae. Plants die. Bacterial decomposition consumes the available oxygen in the aquatic ecosystem. Anoxia condition, devoid of oxygen. All aquatic organisms die due to lack of D.O. degradation of aquatic ecosystem. 4th March 2002. Effects: change in ecosystem. Times eutrophication eventually create detritus layer in the ponds and lakes and produces successively shallower depth of surface water. Times eventually the water body is reduced into marsh whose plant community is transformed from an aquatic environment to recognizable terrestrial ecosystem. Decreased biodiversity times algal blooms restrict the sunlight to penetrate and affects the photosynthesizing plants. It causes death of plants. Times bacteria consumes all the oxygen on decomposition and results in devoid of oxygen. Eventually it leads to death of all living organism in aquatic ecosystem. New species invasion times eutrophication may cause the ecosystem competitive by transforming the normal limiting nutrient to abundant level. This causes shifting in species composition of ecosystem toxicity times some algal blooms when die or eaten, release neuro and hepatotoxins which can kill aquatic organism and pose threat to humans. E.G. Shellfish poisoning. Times depletion of dissolved oxygen level. Times increased incidences of fish kills and loss of desirable fish species and reduction in harvesting times loss of coral reefs. Times decrease in water transparency and increased turbidity. Times affects navigation due to increased turbidity. Times color, yellow, green, red, smell and water treatment problems. Times increased biomass of inedible toxic phytoplankton times increase in bloom of gelatinous zooplankton times increased biomass of benthic and epiphytic algae times unsuitable for aesthetic recreation, and reduction in value of water body. Do you know? The world's tallest tree is a coast redwood in California, measuring more than 360 feet or 110 m. Mitigation times riparian buffer times interfaces between a flowing body of water and land created near the waterways, farms, roads, etc. in an attempt to filter pollution. Times sediments and nutrients are deposited in the buffer zones instead of deposition in water. Times minimizing the non-point pollution. Times nitrogen testing and modeling times N testing is a technique to find the optimum amount of fertilizer required for crop plants. It will reduce the amount of nitrogen lost to the surrounding area. Times treatment of industrial effluents times organic farming and integrated farming system. Times reduction in livestock densities times improving the efficiency of use of fertilizer times treatment of runoff from street and storm drains times reduction in nitrogen emission from vehicles and power plants times increase in efficiency of nitrogen and phosphorus removal from municipal wastewater policies times multi-dimensional in nature should include times education and awareness times research, monitoring and evaluation times regulations. Times fiscal and economic incentives times ecosystem preservation and restoration. 4.4 Harmful algal blooms times algae or phytoplankton are microscopic organisms that can be found naturally in coastal waters. They are major producers of oxygen and food for many of the animals that live in these waters. Times when environmental conditions are favorable for their development, these cells may multiply rapidly and form high numbers of cells, and this is called an algal bloom. Times a bloom often results in a color change in the water. Algal blooms can be any color, but the most common ones are red or brown. These blooms are commonly referred to as red or brown tides. Times most algal blooms are not harmful, but some produce toxins and do affect fish, birds, marine mammals and humans. The toxins may also make the surrounding air difficult to breathe. These are known as harmful algal blooms, HABs. 4th April 2002 Why red tide is a misnomer. Times, red tide, is a common name for such a phenomenon where certain phytoplankton species contain pigments and bloom, such that the human eye perceives the water to be discolored. Times blooms can appear greenish, brown, and even reddish-orange depending upon the type of organism, the type of water, and the concentration of the organisms. Times the term, red tide, is thus a misnomer because blooms are not always red. They are not associated with tides, they are usually not harmful, and some species can be harmful or dangerous at low cell concentrations that do not discolor the water. Times they are scientifically referred as harmful algal blooms, HABs. What are the causes of these blooms? Times blooms occur when several colonies start combining rapidly when conditions such as nutrient concentrations, salinity and temperature are optimal. Times blooms can be due to a number of reasons. Two common causes are nutrient enrichment and warm waters. Times nutrient enrichment of water, especially phosphates and nitrogen, is often the result of pollution and can cause algal blooms. Times water temperature has also been related to the occurrence of algal blooms, with unusually warm water being conducive to blooms. 4th April 2004 How are HABs dangerous to fish and humans? Times HABs can deplete oxygen in water and lead to low dissolved oxygen levels. Times how it depletes oxygen. When masses of algae die and decompose, the decaying process can deplete oxygen in the water, causing the water to become so low in oxygen. Times when oxygen levels become too low, fish suffocate and die. Times some algae species in blooms produce potent neurotoxins that can be transferred through the food web where they affect and even kill the higher forms of life such as zooplankton, shellfish, fish, birds, marine mammals, and even humans that feed either directly or indirectly on them. Do you know? Elephants live in a social hierarchy dominated by older females. Females travel in long-lasting social units of about half a dozen adult females and their offspring, with the unit being led by a single older female, the matriarch. 4th April 2005 Is HABs an environmental hazard? Times yes, it is because these events can make people sick when contaminated shellfish are eaten, or when people breathe aerosolized HAB toxins near the beach. Times in addition, HAB events can result in the closure of shellfish beds, massive fish kills, death of marine mammals and seabirds, and alteration of marine habitats. Times as a consequence, HAB events adversely affect commercial and recreational fishing, tourism, and valued habitats, creating a significant impact on local economies and the livelihood of coastal residents. 4th April 2006 How do we get exposed to HAB toxins? Times most illness associated with HAB exposure is the result of consuming toxins that are present in shellfish or finfish. Times some HAB toxins can become airborne during a bloom and people can become ill by inhaling toxins. 4th April 2007 Is it safe to eat seafood? Times in general, it is safe to eat seafood. Times however, consuming shellfish that have been harvested from waters with high levels of harmful algae and consuming fish that have lesions or that were caught in an area during an algal bloom can result in illness. 448 HABs and climate change times because the growth, toxicity, and distribution of harmful algal bloom, HAB, species are all tied to the environment. Changes in climate can change the occurrence, severity, and impacts of HAB events. 4.5 Wetland ecosystem times wetlands are areas intermediate in character between deep water and terrestrial habitats, also transitional in nature, and often located between them. Times these habitats experience periodic flooding from adjacent deep water habitats and therefore supports plants and animals specifically adapted to such shallow flooding or waterlogging of the substrate, were designated as wetlands. Times they included lake littorals, marginal areas between highest and lowest water level of the lakes, floodplains, areas lying adjacent to the river channels beyond the natural levees and periodically flooded during high discharge in the river, and other marshy or swampy areas where water gets stagnated due to poor drainage or relatively impervious substrata and bogs, fens and mangroves due to similar ecological characteristics. 4th May 2001. Definition times areas of marsh, fen, peatland water, whether natural, or artificial, permanent, or temporary with water that is static, or flowing, fresh, brackish, or salt, including areas of marine water the depth of which at low tide does not exceed 6 mtrs. Downloaded from Characteristics types covered by water, or has waterlogged soil for at least 7 days during the growing season. Times adopted plant life, hydrophytes, times hydric soils, not enough O2 available for some plants. 4th May 2003. Wetlands classification: wetland, inland wetland, coastal wetland, natural man-made times lakes, ponds times oxbow lakes times waterlogged times seasonal times swamp marsh times reservoirs times tanks times waterlogged times ash pond, natural man-made times estuary times lagoon times creek times backwater times bay times coral reef times tidal flat times mangroves times salt marsh times salt pans times aquaculture. 454 Functions of wetlands times habitat to aquatic flora and fauna, as well as numerous species of birds, including migratory species. Times filtration of sediments and nutrients from surface water times nutrients recycling times water purification times floods mitigation times maintenance of stream flow times groundwater recharging times provide drinking water, fish, fodder, fuel, etc. times control rate of runoff in urban areas times buffer shorelines against erosion times comprise an important resource for sustainable tourism, recreation and cultural heritage times stabilization of local climate times source of livelihood to local people times genetic reservoir for various species of plants, especially rice, times supporting specific diversity. 455 Reasons for depletion times conversion of lands for agriculture times overgrazing times removal of sand from beds times aquaculture times habitat destruction and deforestation. Pollution times domestic waste times agricultural runoff times industrial effluents times climate change. 456 Mitigation times survey and demarcation times protection of natural regeneration times artificial regeneration times protective measures times afforestation, percentage survival to be indicated, times weed control times soil conservation measures and afforestation times wildlife conservation times removal of encroachments times eutrophication abatement times environmental awareness. 457 Distinction from lakes times although the Ministry of Environment and Forests has not adopted a clear distinction between lakes and wetlands, the National Lake Conservation Program, NLCP, considers lakes as standing water bodies which have a minimum water depth of 3 m, generally cover a water spread of more than 10 hectares, and have no or very little aquatic vegetation, macrophytes. Times these water bodies are used primarily for drinking water supplies, irrigation and or recreation. Times excessive growth of macrophytes, both submerged and free-floating, generally present in wetland, affects the water quality adversely and interfere with the utilization of the water body. Times however, marginal aquatic vegetation, wetlands, particularly comprising of emergent plants and those inhabiting waterlogged soils, is not only desirable but is to be promoted because it checks erosion, serves habitat for wildlife and helps improve water quality. Times wetlands, generally less than 3 m deep over most of their area, are usually rich in nutrients, derived from surroundings and their sediments, and have abundant growth of aquatic macrophytes. Times they support high densities and diversity of fauna, particularly birds, fish and macroinvertebrates, and therefore, have high value for biodiversity conservation. These shallow lakes are rightfully categorized as wetlands. Times lakes are generally less important when compared to wetland from the viewpoint of ecosystem and biodiversity conservation. 458 Comparison between lake and wetlands. SL No characteristic lake wetland, shallow lake. 1. Origin various process fluvial geomorphic processes. 2. Water turnover permanent or temporary. 3. Water level changes relatively small relatively large. 4. Littoral, Pelagial ratio small large. 5. Thermal stratification yes number 6. Vertical mixing thermally regulated wind regulated. 7. Dominant producer phytoplankton macrophytes. 8. Food chain grazing pathway detritus pathway. 9. Nutrient cycles microbial loops less important microbial loop dominant. 10. Productivity low high. 11. Trophic status oligotrophic mostly eutrophic, except desirable in bogs. 12. Biodiversity generally low generally high. 13. Functions flood control less significant 14. Groundwater recharge negligible low high. 15. Waste treatment no. Yes 16. Management objectives: control of eutrophication, high water quality, biodiversity conservation. Specific functions downloaded from www.ups. India's wetlands types. Wetlands are areas of critical ecological significance, as they support biodiversity, support millions of people directly and indirectly, protect from storms, flood control, improve water quality, supply food, fiber and raw materials. Times India has totally 27,403 wetlands, of which 23,444 are inland wetlands and 3,959 are coastal wetlands. Wetlands occupy 18.4% of the country's area, of which 70% are under paddy cultivation. Times natural wetlands in India range from high-altitude wetlands in Himalayas, floodplains of the major river systems, saline and temporary wetlands of the arid and semi-arid regions, coastal wetlands such as lagoons, backwaters, estuaries, mangroves, swamps and coral reefs, and so on. Do you know? Connemara teak is one of the largest living teak tree in the world. It has an amazing girth of 6.48 m and a crown height of 48.75 m. It is believed to be around 400 years old. According to the local tribal belief here, when this tree was tried to cut down, the blood spurted out from the place of cut. This tree was being since then worshipped by the local tribes in Parambikulam as virgin tree. Connemara, Kanni, means virgin. This tree has been awarded Mahavriksha Puraskar by the Government of India for 510 National Wetlands Conservation Program, NWCP. Times NWCP was implemented in the year 1985 to 86. Times under the program, 115 wetlands, annexure, have been identified by the ministry which require urgent conservation and management interventions. Aim times conservation of wetlands to prevent their further degradation and ensuring their wise use for the benefit of local communities and overall conservation of biodiversity. Objectives times to lay down policy guidelines for conservation and management of wetlands in the country. Times to provide financial assistance for undertaking intensive conservation measures in the identified wetlands. Times to monitor implementation of the program, and to prepare an inventory of Indian wetlands. Times the central government is responsible for overall coordination of wetland conservation programs and initiatives at the international and national levels. It also provides guidelines, financial and technical assistance to state gov. Times since the land resources belong to them, the state government's UT administration are responsible for management of wetlands and implementation of the NWCP for ensuring their wise use. 4th May 2011 Criteria for identification of wetlands of national importance. Times criteria for identification of wetlands of national importance under NWCP are same as those prescribed under the Ramsar Convention on Wetlands and are as given below. Times sites containing representative, rare or unique wetland types, I, if it contains a representative, rare, or unique example of a natural or near-natural wetland type found within the appropriate biogeographic region. Times criteria based on species and ecological communities. 2. If it supports vulnerable, endangered, or critically endangered species, or threatened ecological communities. 3. If it supports populations of plant and or animal species important for maintaining the biological diversity of a particular biogeographic region. 4. If it supports plant and or animal species at a critical stage in their life cycles, or provides refuge during adverse conditions. Times specific criteria based on water birds. If it regularly supports 20,000 or more water birds. 6. If it regularly supports 1% of the individuals in a population of one species or subspecies of water birds. Times specific criteria based on fish. 7. If it supports a significant proportion of indigenous fish subspecies, species or families, life history stages, species interactions and or populations that are representative of wetland benefits and or values and thereby contributes to global biological diversity. 8. If it is an important source of food for fishes, spawning ground, nursery and or migration path on which fish stocks, either within the wetland or elsewhere, depend. Specific criteria based on water life and culture downloaded from If it is an important source of food and water resource, increased possibilities for recreation and ecotourism, improved scenic values, educational opportunities, conservation of cultural heritage, historic or religious sites. 4.5.12 Montrose Record. Montrose Record is the principal tool under the Ramsar Convention, is a register of wetland sites on the list of wetlands of international importance. It highlights those sites where adverse changes in ecological character have occurred, are occurring, or are likely to occur as a result of technological developments, pollution or other human interference, and which are therefore in need of priority conservation attention. It is maintained as part of the Ramsar list. Montrose Record are employed to identify priority sites for positive national and international conservation attention. Sites may be added to and removed from the record only with the approval of the contracting parties in which they lie. Montrose Record sites in India. Chilika Lake, Odisha was placed on the Montrose Record in 1993 due to siltation, which was choking the mouth of the lake. Following the rehabilitation efforts of the government, it was removed from the record in 2002. For this achievement, the Chilika Development Authority received the Ramsar Wetland Conservation Award for 2002. Loktak Lake, Manipur was included on the Montrose Record in 1993, signifying habitat degradation, as a result of ecological problems such as deforestation in the catchment area, infestation of water hyacinth and pollution. The construction of a hydroelectric power plant has caused the local extinction of several native fish species. Keoladeo National Park, Rajasthan was placed on the Montrose Record in 1990 due to water shortage and unbalanced grazing regime around it. The invasive growth of the grass Paspalum distichum has changed the ecological character of large areas of the site, reducing its suitability for certain waterbird species, notably the Siberian crane. Loktak Lake and Keoladeo National Park are the two Montrose Record sites in India. Nainampur Lake, first FTW Lake. The Nainampur Lake, Hyderabad is the largest floating treatment wetland in the country. Floating treatment wetland works on the basis of hydroponics technique. Hydroponics permits plants to grow on the water with the help of sunlight, no need of soil. A floating island unit is essentially a platform designed using styrofoam, bamboo, gunny bags and coir. It performs the function of a wetland. 4.6 Estuary ecosystem. Times estuaries are located where river meets the sea. Estuaries are water bodies where the flow of fresh water from river mixes with salt water transported, by tide, from the ocean. Estuaries are the most productive water bodies in the world. They are located at the lower end of a river and are subject to tidal fluctuations. Times estuaries are either once or twice daily washed by the sea water. 461 characters. Times an estuary is a semi-enclosed coastal body of water with one or more rivers or streams flowing into it. Times it has a free connection with open sea. Times the complete salinity range from 0 to 35 ppt is seen from the head, river end, to the mouth, sea end, of an estuary. Times an estuary has very little wave action, so it provides a calm refuge from the open sea. It provides the shelter for some of the animals. Times it is the most productive region as it receives the high amount of nutrients from fresh and marine water. Times estuaries are most heavily populated areas throughout the world, with about 60% of the world's population living along estuaries and the coast. Coastal lakes which have their connection with the sea through small openings are better known as lagoons or backwaters. They exhibit a gradient in salinity from freshwater to marine depending upon the extent of influence of the sea water. Estuary formation. Most estuaries can be grouped into 4 geomorphic categories based on the physical processes responsible for their formation. 1. Rising sea level. 2. Movement of sand and sandbars. 3. Glacial processes. And 4. Tectonic processes. Estuaries are typically classified by their geomorphological features or by water circulation patterns and can be referred to by many different names, such as bays, harbors, lagoons, inlets, etc. Downloaded from www.upskmaterials.com/downloaded from https://t.me/ups. The banks of estuarine channels form a favored location for human settlements, which use the estuaries for fishing and commerce, but nowadays also for dumping civic and industrial waste. Estuaries are usually biologically highly productive zones. They also act as a filter for some dissolved constituents in river water. These precipitate in the zone where river water meets sea water. More important is the trapping of suspended mud and sand carried by rivers, which leads to delta formations around estuaries. 462 A healthy estuary. A healthy estuary supports a host of plants and animals. It stores and recycles nutrients, traps sediment and forms a buffer between coastal catchments and the marine environment. It also absorbs traps and detoxifies pollutants, acting as a natural water filter. When all such processes remain functional, an estuary is considered to be healthy state. Estuaries support diverse habitats, such as mangroves, salt marshes, seagrass, mudflats, etc. 463 Life in estuary. Only certain types of plants and animals specially adapted to the brackish estuarine waters flourish in the estuaries. Factors influencing the growth and distribution of organism in an estuary are its salinity and the amount of flooding. Estuaries are homes to all kinds of terrestrial or land-based plants and animals, such as wood storks, pelicans, coniferous and deciduous trees and butterflies. Estuaries are also homes to unique aquatic plants and animals, such as sea turtles and sea lions, sea catfish, saltworts, eelgrass, salt grasses, cord grasses, seagrass, sedge and bulrush. Predators are important to the estuary because of their end position in most consumer food chains. 4th June 2004 Benefits of estuarine ecosystem. Environmental benefits water quality regulation and groundwater recharge habitat, breeding and nursery grounds for plants and animals biological productivity social benefits community values indigenous values recreation values knowledge research values economic benefits commercial fishing ports and harbors navigation tourism agriculture, aquaculture and industry storm and erosion protection. 465 India estuarine ecosystem The country has 14 major, 44 medium and 162 minor rivers drains into the sea through various estuaries. Estuaries are an important and distinct component of the coastal landscape with highly complex ecosystems, varying physical chemical properties and having highly diverse flora and fauna. Major estuaries occur in the Bay of Bengal. Many estuaries are locations of some of the major seaports. Most of the India's major estuaries occur on the east coast. In contrast, the estuaries on the west coast are smaller. 466 Issues of Indian estuarine ecosystem. The specific issues which have affected the estuarine environment in the country are: 1. Water flow. Changes in water flow in various estuaries, either far in excess or much lower than required, e.g., Hooghly, Narmada, Krishna, Godavari, Pulicat, etc. Modifications of the estuarine catchments, e.g. most of the Indian estuaries. 2. Pollution and water quality. Pollution through industries and combined city sewage, e.g., all the Indian estuaries. 3. Recreation and tourism. Recreational boating, e.g., Hooghly WB, Chilika, Orissa. Recreational fishing, kg, Chilika. Navigation, e.g., Hooghly. 4 ports and shipping times dredging, e.g., Hooghly, downloaded from www.upskmaterials.com/
Shipping, RG,
Hooghly,
5
5 land use times expansion of urban and rural settlements, E.G., Hooghly, Krishna, Koveri, Pulicat, times marinas, groin, land reclamation and other structures, e.g., Hooghly, Pulicat, times mining
and industries, e.g., Hooghly, Estuary, Goa, times agriculture, e.g., all the estuaries, times dumping of solid wastes, all the Indian estuaries. 6. Commercial fishing and aquaculture times over exploitation of target fish stock due to increased demand, e.g., all the Indian estuaries, times reclaiming. The fringed areas for intensive aquaculture in pens, times obstructing the migratory routes of fish and prawn recruitment, e.g., Chilika, Pulicat, times polluting the environment through feeding of stocked fish and prawn in pens, Chilika, times destruction of biodiversity through prawn seed collection and operation of small mesh nets, e.g., Hooghly, Chilika, Pulicat. 7. Climate change times submergence of catchment areas due to rise in water level, e.g., all the major Indian estuaries, times change in biodiversity profile, affecting the production and productivity, e.g., all the major Indian estuary. Do you know? Snakes generally lay eggs. Some snakes, such as boas, rattlesnakes and garter snakes, give birth to live young. 4.7 Mangroves times mangroves are the characteristic littoral plant formation of tropical and subtropical sheltered coastlines. Mangroves are trees and bushes growing below the high water level of spring tides which exhibits remarkable capacity for salt water tolerance. FAO. 4.7 Characteristics of mangroves times they are basically evergreen land plants growing on sheltered shores, typically on tidal flats, deltas, estuaries, bays, creeks and the barrier islands. Times the best locations are where abundant silt is brought down by rivers or on the backshore of accreting sandy beaches. Times their physiological adaptation to salinity stress and to waterlogged anaerobic mud is high. Times they require high solar radiation and have the ability to absorb fresh water from saline brackish water. Times it produces pneumatophores, blind roots, to overcome respiration problem in the anaerobic soil conditions. Pneumatophores times mangroves occur in variety of configurations. Some species, e.g. Rhizophora, send arching prop roots down into the water, while other, e.g. Avicennia, send vertical, pneumatophores, or air roots up from the mud. Times most mangrove vegetation has lenticulated bank which facilitates more water loss, produces coppices. Leaves are thick and contain salt-secreting glands. Mangrove tree downloaded from www.upskmaterials.com. Mangroves exhibit
viviparity mode of reproduction, i.e. seeds germinate in the tree itself, before falling to the ground. This is an adaptive mechanism to overcome the problem of germination in saline water. Times some secrete excess salt through their leaves, as if you look closely, you can see crystals of salt on the back of the leaves, others block absorption of salt at their roots. Times adventitious roots which emerged from the main trunk of a tree above ground level are called stilt roots. Stilt roots, do you know? The word amphibian means two lives. Amphibians spend their lives in the water and on land. All amphibians begin their life in water with gills and tails. As they grow, they develop lungs and legs for their life on land. Members of this animal class are frogs, toads, salamanders, newts, and caecilians or blindworms. Amphibians shed their skin as they grow. Usually the shed skin is eaten. 4th July 2002 Mangrove profile in India times the mangroves of Sundarbans are the largest single block of tidal holophytic mangroves of the world. The major species of this dense mangrove forest include Heritiera fames, Rhizophora spp, Brighiera spp, Cereops decandra, Sonaratia spp and Avicennia spp. Nipa fruticans are found along the creeks. This mangrove forest is famous for the Royal Bengal tiger and crocodiles. Mangrove areas are being cleared for agricultural use. Times the mangroves of Bhita, Orissa, which is the second largest in the Indian subcontinent, harbor high concentration of typical mangrove species and high genetic diversity.
Saline water.
Times some secrete excess salt through their leaves as if you look closely, you can see
Crystals of
crystals of
salt.
salt.
The
The
leaves.
leaves,
Others
others
block
block
absorption
absorption
of
of salt at their roots.
times
Times
adventitious
adventitious
roots
roots which emerge
from
from the main
trunk.
trunk of a tree.
Stilt root. Times some secrete excess salt through their leaves
As if you look closely, you can see
crystals of salt on the back of the leaves.
others block absorption of salt at their roots. Times adventitious roots which emerged from the main trunk of a tree above ground level are called stilt roots. Stilt roots, do you know? The word amphibian means two lives. Amphibians spend their lives in the water and on land. All amphibians begin their life in water with gills and tails. As they grow, they develop lungs and legs for their life on land. Members of this animal class are frogs, toads, salamanders, newts, and caecilians or blindworms. Amphibians shed their skin as they grow. Usually the shed skin is eaten. 4th July 2002 Mangrove profile in India times the mangroves of Sundarbans are the largest single block of tidal holophytic mangroves of the world. The major species of this dense mangrove forest include Heritiera fames, Rhizophora spp, Brighiera spp, Cereops decandra, Sonaratia spp and Avicennia spp. Nipa fruticans are found along the creeks. This mangrove forest is famous for the Royal Bengal tiger and crocodiles. Mangrove areas are being cleared for agricultural use. Times the mangroves of Bhita, Orissa, which is the second largest in the Indian subcontinent, harbor high concentration of typical mangrove species and high genetic diversity. Times mangrove swamps occur in profusion in the intertidal mudflats on both sides of the creeks in the Godavari-Krishna deltaic regions of Andhra Pradesh. Times mangroves of Pichavaram and Vedaranyam are degraded mainly due to construction of aquaculture ponds and salt pans.
Mangrove of Gujarat and India, Sundargroup, Mahanagroup, Krishna Godavari Mangrove, Nagari Mangrove, Goa Mangrove, Kaveri Deltaic Mangrove, Andaman and Nicobar Island Mangrove. These are Indian mangrove profile.
Indian mangrove profile times on the west coast of India. Mangroves, mostly scrubby and degraded, occur along the intertidal region of estuaries and creeks in Maharashtra, Goa and Karnataka. Times the mangrove vegetation in the coastal zone of Kerala is very sparse and thin. Times in Gujarat, northwest coast, mangroves Avicennia marine, Avicennia officinalis and Rhizophora mucronata are found mainly in Gulf of Kutch and the Kori Creek. Times mangroves are of scrubby type with stunted growth, forming narrow, discontinuous patches on soft clayey mud. Times the condition of the mangroves is improving, especially in the Coral Creek region, which is a paleodelta of the Indus River. Times in size, mangroves range from bushy stands of dwarf down.
Mangroves found in Gulf of Kutch.
To taller stands found in the Sundarban. Times on the Andaman and Nicobar Islands, the small tidal estuaries, neritic inlets and the lagoons support a dense and diverse undisturbed mangrove flora. 473 Role of mangroves. Times mangrove plants have additional, special roots such as prop roots, pneumatophores which help to impede water flow and thereby enhance the deposition of sediment in areas where it is already occurring, stabilize the coastal shores, provide breeding ground for fishes. Times mangroves moderate monsoonal tidal floods and reduce inundation of coastal lowlands. Times it prevents coastal soil erosion. Times it protects coastal lands from tsunami, hurricanes and floods. Times mangroves enhance natural recycling of nutrients. Times mangrove supports numerous flora, avifauna and wildlife. Times provide a safe and favorable environment for breeding, spawning, rearing of several fishes. Times it protects coastal inland from adverse climatic elements. Times it supplies woods, firewood, medicinal plants and edible plants to local people. Times it provides numerous employment opportunities to local communities and augments their livelihood. Do you know? The king cobra is not only an excellent climber but a super swimmer as well. They live in forests near streams. Fine, anoxic sediments deposited under mangroves act as sinks for a variety of heavy, trace metals which are scavenged from the overlying seawater by colloidal particles in the sediments. By cleaning our air, they taking in carbon dioxide, storing the carbon in their roots, leaves, branches and in its surrounding silt, and release oxygen back to the atmosphere, along with a little methane gas. 474 Threat. Times they are destroyed for conversion of area for agricultural purpose, fuel, fodder and salinization, minig, oil spills,
Aquacultural,
shrimp farming, use of chemical pesticides and fertilizers, industrial purposes. 4.8 Coral reefs. Times coral is actually a living animal. Coral has a symbiotic relationship, each gives something to the other and gets something back in return, with zooxanthellae, microscopic algae which live on coral, instead of living on the sea floor. The algae lives up on the coral which is closer to the ocean surface and so that the algae gets adequate light. Coral. Times zooxanthellae assist the coral in nutrient production through its photosynthetic activities. These activities provide the coral with fixed carbon compounds for energy, enhance calcification and mediate elemental nutrient flux. Times the tissues of corals themselves are actually not the beautiful colors of the coral reef, but are instead clear, white. The corals receive their coloration from the zooxanthellae living within their tissues. Times the host coral polyp in return provides its zooxanthellae with a protected environment to live within, and a steady supply of carbon dioxide for its photosynthetic processes. Times there are two types of corals, hard corals and soft corals, such as sea fans and gorgonians. Only hard corals build reefs. Times the builders of coral reefs are tiny animals called polyps. As these polyps thrive, grow, then die, they leave their limestone, calcium carbonate, skeletons behind. The limestone is colonized by new polyps. Therefore, a coral reef is built up of layers of these skeletons covered ultimately by living polyps. Downloaded.
The reef building,
or hermatypic corals can form a wide range of shapes. Coral reefs may be branched, table-like, or look like massive cups, boulders or knobs. While the majority of coral reefs are found in tropical and subtropical water, there are also deep water corals in colder regions. 4th August 2001 Cold water corals. Cold water corals inhabit deep, cold, 39 to 55 degrees F, water. The United Nations Environment Programme reports that there are more cold water coral reefs worldwide than tropical reefs. There are only about 6 different coral species associated in building with these reefs. The largest cold water coral reef is the Roast Reef of Norway. For it too features they occur in shallow tropical areas where the sea water is clean, clear and warm. The coral reef cover in Indian waters is roughly estimated up to 19,000 sq km. Coral reefs are one of the most productive and complex coastal ecosystems with high biological diversity. The high productivity is owing to the combination of its own primary production and support from its surrounding habitat. Reef-building corals are a symbolic association of polyps, coral animals, and zooxanthellae, the microscopic algae. The corals are generally slow-growing colonies of animals while zooxanthellae are fast-growing plants. Even though corals live in nutrient-poor waters, their capability to recycle the scarce nutrients, by the whole nutrient community, is enormous. In coral reef ecosystem, many invertebrates, vertebrates, and plants live in close association to the corals, with tight resource coupling and recycling, allowing coral reefs to have extremely high productivity and biodiversity, such that they are referred to as the tropical rainforests of the oceans. 4th August 2003 Classification and their location. The coral reefs are classified depending on their locations into fringing, patch, barrier and atoll. The fringing reefs are contiguous with the shore and they are the most common, by occurring reef form, found in Andamans. Shorebird of offshore reef structures as seen in the Balk Bay, Gulf of Mannar and Gulf of Kutch. Barrier reefs are linear offshore reef structures that run parallel to coastlines and arise from submerged shelf platforms. The water body between the reef and the shore is termed as lagoon. Barrier reefs are seen in Nicobar and Lakshadweep. Atolls are circular or semicircular reefs that arise from subsiding seafloor platforms as coral reef building keeps ahead of subsidence. The examples are the atolls of Lakshadweep and Nicobar. When the reef building do not keep pace with subsidence, reefs become submerged banks as seen in Lakshadweep. Seagrasses grow on Kavlaki Atoll, mangroves are prevalent on Andaman and Nicobar coral reefs. Among the 4 major reef areas of India, Andaman and Nicobar Islands are found to be very rich in species diversity, followed by the Lakshadweep Islands, the Gulf of Mannar and finally the Gulf of Kutch. 4 functions of coral reefs. Coral reefs are natural protective barriers against erosion and storm surge. The coral animals are highly adapted for capturing plankton from the water, thereby capturing nutrients. Largest biogenic calcium carbonate producer. They provide substrate for mangroves. Coral reefs provide habitat for a large variety of animals and plants including avifauna. 485 Threat 1. Natural causes may be due to the outbreak of reef-destroying mechanisms, bleaching, and depletion of essential symbiotants. 2 Anthropogenic causes may be due to chemical pollution, pesticides, cosmetics, etc., industrial pollution, mechanical damage, nutrient loading or sediment loading, dredging, shipping, tourism, mining or collection, thermal pollution, intensive fishing, etc. Times coral reef ecosystems worldwide have been subject to unprecedented degradation over the past few decades. Disturbances affecting coral reefs include anthropogenic and natural events. Recent accelerated coral reef decline seems to be related mostly to anthropogenic impacts, overexploitation, overfishing, increased sedimentation.
and nutrient overloading.
Natural disturbances which cause damage to coral reefs include violent storms, flooding, high and low temperature extremes, El Niño Southern Oscillation, ENSO, events, subaerial exposures, predatory outbreaks and epizootics.
Times
Coral
coral
reef
reef
bleaching is a common stress response of corals to many of the various disturbances mentioned above. 4x6 coral bleaching times bleaching, or the paling of coral color occurs when I. The densities of zooxanthellae decline and or 2. The concentration of photosynthetic pigments within the zooxanthellae fall. Coral bleaching times when corals bleach they commonly lose 60 to 90% of their zooxanthellae and each zooxanthella may lose 5,000 and 80% of its photosynthetic pigments. Times if the stress causing bleaching is not too severe and if it decreases in time, the affected corals usually regain their symbiotic algae within several weeks or a few months. Times if zooxanthellae loss is prolonged, i.e. if the stress continues and depleted zooxanthellae populations do not recover, the coral host eventually dies. Times high temperature and irradiance stressors have been implicated in the disruption of enzyme systems in zooxanthellae that offer protection against oxygen toxicity. Times photosynthesis pathways in zooxanthellae are impaired at temperatures above 30 degrees Celsius. This effect could activate the dissociation of coral-algal symbiosis. Times low or high temperature shocks results in zooxanthellae low as a result of cell adhesion dysfunction. Times this involves the detachment of cnidarian endodermal cells with their zooxanthellae and the eventual expulsion of both cell types. 4x7 ecological causes of coral bleaching times as coral reef bleaching is a general response to stress. It can be induced by a variety of factors, alone or in combination. It is therefore difficult to unequivocally identify the causes for bleaching events. The following stressors have been implicated in coral reef bleaching events. Temperature, major cause, times coral species live within a relatively narrow temperature margin, and anomalously low and high sea temperatures can induce coral bleaching. Bleaching is much more frequently reported from elevated seawater temperature. Bleaching events also occur during sudden temperature drops accompanying intense upwelling episodes, seasonal cold air outbreaks. Do you know? All spiders produce silk but not all spiders spin webs. Silk is used for climbing, to create webs, to build smooth walls in burrows, build egg sacs, and wrap prey. Solar irradiance times bleaching during the summer months. During seasonal temperature and irradiance maxima often occurs disproportionately in shallow living corals and on the exposed summits of colonies. Solar radiation has been suspected to play a role in coral bleaching. Both photosynthetically active radiation, PA, 400-700 nm, and ultraviolet radiation, UVR, 280-400 nm, have been implicated in bleaching. Subaerial exposure times sudden exposure of reef flat corals to the atmosphere during events such as extreme low tides, ENS or related sea level drops or tectonic uplift can potentially induce bleaching. Sedimentation times relatively few instances of coral bleaching have been linked solely to sediment. It is possible, but has not been demonstrated, that sediment loading could make zooxanthellate species more likely to bleach. Fresh water dilution times rapid dilution of reef waters from storm-generated precipitation and runoff has been demonstrated to cause coral reef bleaching. Generally, such bleaching events downloaded from are rare and confined to relatively small, near-shore areas. Inorganic nutrients times rather than causing coral reef bleaching, an increase in ambient elemental nutrient concentrations, e.g. ammonia and nitrate, actually increases zooxanthellae density 2 to 3 times. Although eutrophication is not directly involved in zooxanthellae loss, it could cause secondary adverse effects such as lowering of coral resistance and greater susceptibility to diseases. Xenobiotics times zooxanthellae loss occurs during exposure of coral to elevated concentrations of various chemical contaminants, such as coke, herbicides and oil. Because high concentrations of xenobiotics are required to induce zooxanthellae loss, bleaching from such sources is usually extremely localized and/or transitory. Epizootics times pathogen-induced bleaching is different from other sorts of bleaching. Most coral diseases cause patchy or whole colony death and sloughing of soft tissues, resulting in a white skeleton, not to be confused with bleached corals. A few pathogens have been identified that cause translucent white tissues, a protozoan. Do you know? India updated its National Biodiversity Action Plan, NBAP, and also developed 12 national biodiversity targets in 2014 in line with 20 global HE biodiversity targets. 4.9 govern ENT measures to protect mangrove forest and coral reefs, or coastal ecosystem, times the government seeks to protect, sustain and augment mangroves and coral reef in the country by both regulatory and promotional measures. Times under the regulatory measures, the Coastal Regulation Zone, CRZ, Notification, 2011, and the Island Protection Zone, IPZ, Notification 2011 regulates the development activities along the seacoast and tidal-influenced water bodies. Times the mangroves and coral reef areas are categorized as ecological sensitive areas, CRZI, where no new constructions are permitted except projects relating to Department of Atomic Energy, pipelines, conveying systems including transmission lines, installation of weather radar for monitoring of cyclones movement and prediction by Indian Meteorological Department and construction of Trans-Harbour Sea Link and without affecting the tidal flow of water. Times to enforce and implement the CRZ and IPZ notifications, the Ministry of Environment and Forests has constituted the national and state UT-level coastal zone management authorities. Do you know? The ministry has partnered with the United Nations Development Programme, UNDP, in a global project on biodiversity finance initiative, BioFin. The Ministry of Environment and Forests also provides financial assistance to coastal states' union territories, who so request, under its centrally sponsored scheme for conservation and management of mangroves and coral reef. Times in addition, coral reef is included in Schedule I of the Wildlife Protection Act, 1972, which affords it the highest degree of protection. Times further protected areas, with 4 national parks, 96 sanctuaries and 3 marine biosphere reserve have been created all over the country under the provisions of the Wildlife Protection Act, 1972 to conserve marine life including coral reef. Times the Wildlife Crime Control Bureau has also been set up to strengthen the enforcement of law for control of poaching and illegal trade in wildlife and its products. 4.10 Key initiatives to protect marine and coastal environments. 4.01 Coastal Ocean Monitoring and Prediction System, COMAPS, times being implemented from 1991. Times assesses the health of coastal waters and facilitates management of pollution-related issues. Program was restructured and modified in 2000-2001 to include pollution monitoring, liaison, regulation and legislation, and consultancy services. 4.02 Land-Ocean Interactions in the Coastal Zone, LOIS, times launched in 1995. Times investigates the effects of global change on the coastal zone. Times aims to develop, on a scientific basis, the integrated management of coastal environments. Do you know? Male snakes will try to attract a female by doing a type of play fighting with other males to gain female attention. They do not try to kill each other. Just win the fight. 4103 Integrated Coastal and Marine Area Management, ITMAM. Times launched in 1998. Times aims at integrated management of coastal and marine areas. Times model plans for Chennai, Goa and Gulf of Kutch being prepared. 4104 Society of Integrated Coastal Management, SICOM. Times launched in 2010. Times major national initiative to protect coastal ecosystems. Times a professional body with experts in various aspects of coastal science and management. 4105 Institutions for Coastal Management. Times the Notification on Coastal Regulation Zone, CRZ, 1991, as amended from time to time, aims at protecting coastal stretches in India. Times India has created institutional mechanisms such as National Coastal Zone Management Authority, NCSMA, and State Coastal Zone Management Authority, SCMA, for enforcement and monitoring of the CRZ notification. Times these authorities have been delegated powers under Section 5 of the Environmental Protection Act, 1986 to take various measures for protecting and improving the quality of the coastal environment and preventing, abating and controlling environmental pollution in coastal areas. 4.11 Ganga Action Plan. The Ganga Action Plan was launched on 14 January 1986 with the main objective of pollution abatement, to improve water quality by interception, diversion and treatment of domestic sewage and toxic and industrial chemical wastes present from identified grossly polluting units entering into the river. After reviewing the effectiveness of the Ganga Action Plan, the government announced the Mission Clean Ganga project on 31 December 2009 with the objective that by 2020, no municipal sewage and industrial waste would be released in the river without treatment, with the total budget of around 15,000 rupees crore. The government also established the National Ganga River Basin Authority, NGRBA, chaired by the Prime Minister, with the objective to ensure effective abatement of pollution and conservation of the river Ganga, by adopting a river basin approach for comprehensive planning and management. 4.12 Namami Ganga Program. Accordingly, an integrated Ganga conservation mission called Namami Gange has been proposed to be set up, and a sum of 2,037 rupees crores has been set aside for the purpose of conservation and improvement of the Ganga. In addition, a sum of 100 rupees crores has been allocated for developments of ghats and beautification of river fronts at Kedarnath, Haridwar, Kanpur, Varanasi, Allahabad, Patna and Delhi in the current financial year. Accordingly, Namami Gange approaches Ganga rejuvenation by consolidating the existing ongoing efforts and planning for a concrete action plan for future. The interventions at ghats and river fronts will facilitate better citizen connect and set the tone for river-centric urban planning process. Following are proposed to be taken up under Namami Gange program. I. Nirmal Dhara ensuring sustainable municipal sewage management. Downloaded from www.upskmaterials.com/downloaded from https://t.me/ups_materials_hub www.visionias.net. Shankar IAS Academy. Environment, all rights reserved. No part of this material may be reproduced in any form or by any means, without permission in writing. Times Project Prioritization in coordination with Ministry of Urban Development. Times Incentive for states to take up projects on Ganga mainstem by providing an additional share of central grants for sewerage infrastructure. Times Uniform Standards for both MOUD scheme and Namami Gange program. 10 years mandatory O&M by the same service provider at par with NGRBA program and PPP. Mandatory reuse of treated water. Times expanding coverage of sewerage infrastructure in 118 urban habitations on banks of Ganga. Estimated cost by MOUD is rupees 51,000 crores. 2. Nirmal Dhara managing sewage from rural areas. Times Ministry of Drinking Water and Sanitation scheme for all Ganga Bank Gram Panchayats. 1632. Free from open defecation by 2022, at a cost of rupees 1,700 crores as central share. 3. Nirmal Dhara managing industrial discharge times making zero liquid discharge mandatory times rationalized water tariff to encourage reuse times real-time water quality monitoring. 4. Aviral Dhara times enforcing river regulatory zones on Ganga banks times rational agricultural practices, efficient irrigation methods times restoration and conservation of wetlands. We. Ensuring ecological rejuvenation by conservation of aquatic life and biodiversity. 6. Promotion of tourism and shipping in a rational and sustainable manner. 7. Knowledge management on Ganga through Ganga Knowledge Center leading to a Ganga University of River Sciences. NRI Ganga Fund. NRIs have been a very important contributor to the development process in India, in areas such as education, health and preservation of culture. In this context, to harness their enthusiasm to contribute towards the conservation of the 52 Shankar IAS Academy Environment All Rights
52 Shankar. NRI Ganga Fund.
NRIs have been a very important contributor to the development process in India, in areas such as education, health and preservation of culture. In this context, to harness their enthusiasm to contribute towards the conservation of the river Ganga, NRI Fund for Ganga will be set up which will finance special projects. NRI Ganga Fund could be set up under the aegis of Ministry of Overseas Indian Affairs or Ministry of Finance with focus on funds sourcing and corpus management. 4.13 Clean Ganga Fund. The main features of Clean Ganga Fund, CGF, are considering that there is a need to increase people's participation from across the country and abroad. It is proposed to set up a Clean Ganga Fund, CGF, with voluntary contributions. Times CGF will have the objective of contributing to the national effort of improving the cleanliness of the river Ganga with the contributions received from the residents of the country, NRIs, PIO and others. Times CGF will be operated through a bank account by a trust to be headed by the Finance Minister. The Secretariat of the trust will be set up in Ministry of Water Resources, River Development and Ganga Rejuvenation under the Mission Director, Clean Ganga. Times domestic donors to the fund shall be eligible for tax benefits as in the case of Swachh Bharat Kosh. Foreign donors could get suitable tax exemptions in domestic law, wherever permissible. Times CGF will explore the possibility of setting up daughter funds in other jurisdictions, countries of high donor interest such as USA, UK, Singapore, UAE, etc. to enable tax benefits to donors in their respective jurisdictions. Times CGF will be catalytic in nature and will identify and fund specific projects which could be pilot projects, R&D projects, innovative projects or other focused projects. The fund will define specific and measurable objectives to form the basis for planning, funding, and evaluation.
Broad activities that will be
Financed from the Clean Ganga Fund, CGF, fund are times activities outlined under the Namami Gange program for cleaning of river Ganga. Times control of non-pond pollution from agricultural runoff, human defecation, cattle wallowing, etc. Times setting up of waste treatment and disposal plants along the river around the cities. Times conservation of the biotic diversity of the river. Downloaded from www.ups.
Community-based activities
To reduce polluting human interface with the river. Times development of public amenities including activities such as gut redevelopment. Times research and development and innovative projects. Times research and development projects and innovative projects for new technology and processes for cleaning the river. Times independent oversight through intensive monitoring and real-time reporting. Times any other activity as approved by the Trust. Recent measures. Times Union Environment Ministry has taken up a new strategy for conservation and rejuvenation of major river water systems. The new strategy takes into account the entire river basin, which is contributing its flow to the particular river stretch for conservation. Times the present strategy for conservation of rivers is limited only to tackling pollution load from domestic wastewater and regulation of industrial pollution. The new approach is a holistic one for rejuvenation of rivers, wherein water management and environment management are taken together for implementation to restore the lost ecology of the polluted stretches of the rivers. Downloaded from www.untitled.com